rugby, science always needs to be conducted in a fair way, otherwise we can't take it seriously. There are many variables in an experiment that you need to think about, some which are harder to control than others. Which variables will you change, and which will need to stay the same? What will you be measuring, and how will you make sure that the test is fair? In the bungee experiment, our aim is to investigate energy transfer. Remember, energy is never destroyed or created, but passes from object to object. This is known as energy conservation. We want to demonstrate a link between elastic potential energy and kinetic energy. The same link you can see in archery when an arrow is fired. In our experiment, we will demonstrate this link by stretching and releasing an elastic band. Our prediction: the larger the stretch, the more elastic potential energy will be stored in the elastic band, and the further it will travel. Right then, shall we get on? So, what are the variables we need to be aware of to keep the bungee experiment fair? The independent variable is the part of the experiment we are going to change. This will be the length the elastic band is stretched. We will increase the stretch by 10 centimeters each time. The dependent variable is the part of the experiment we are going to measure. This will be the distance the elastic band travels when released. Controlled variables are what stay the same each time and are really important in fair testing. Here, our controlled variables are the width of the band, the angle of projection, and the temperature. Each of these variables could cause different results in the experiment if they are not controlled. We will control these variables by using the same elastic band each time, using a ruler to ensure our projection is consistent, and performing each stretch under the same atmospheric conditions. Everything else that might affect the experiment is also a variable. We call these systematic errors and random errors, and it's good to be aware of them. A random error will give you the wrong results inconsistently. One example is the lighting conditions. If they are bad, could they be affecting your reading of the measurement? Does it say 10 centimeters or 12? A systematic error will give you the wrong results but in a predictable way. This would happen if your equipment, like a thermometer, isn't calibrated correctly. It will always give you the wrong reading, but in a consistent way. So there you have it. Always be aware of the variables and keep your tests fair.